Alright guys, here's what I grabbed for probes that were hanging on the wall. What was left of the probes. And I'll show you. Alright, this is the original, one of the original probes. Well, we may have replaced them over the years, but for the Sencore. So what you got is you got the typical BNC connection, and then there's a compensation circuit inside here, and there's a little set screw in there for that, and then there's this extra wire here. This is for your DC input right there, okay? And then on the other end you've got the probe, and it came with different attachments. So if you unscrew this, you've got your pinpoint here for getting right down on a, you know, like if you want to get onto an IC leg, or if you're doing, you know, in circuit analysis of the, and you want to hook onto a point like a leg on a transistor or something like that, you could do it there. But you got to ground it. So the ground is actually, it clips in here, and there were various size ground leads. I'll get to that in a second. And this is a 10 multiplier 10 probe, so that's not a direct. So if you use a direct probe, you're going to have problems with this. This is a direct probe. I don't even remember what the purpose of this probe is, but this is, you could use this, but you're gonna have to compensate for the fact that it's not multiplying by 10, that it's direct. And this is max 500 volt peak to peak. Oh, while I'm on the subject, that was the other big innovation with this Sencore oscilloscope back in the day. Prior to the advent of this oscilloscope, television service technicians were unable to scope the collector lead of the horizontal output transistor on a television set. So remember I was talking about that high voltage that goes to this screen, to the CRT? Well, the horizontal circuit in one of those old television sets was what was responsible for generating that high voltage, and also for the scan that we're looking at right now. The fact that it's moving horizontally, that's happening because there's a device on the neck of the tube called the deflection yoke. It's a big coil, and there's waveforms going to that right now that are deflecting the cathode, the electron beam. So the electron beam's coming from the cathode, and it's hitting the back of this phosphorus screen and causing it to light. And what's making it move like that is the fact that there's a signal being sent to this coil, and it's deflecting it. All right. So, anyways, that horizontal frequency and the high voltage is all developed by the horizontal circuit in the TV set. So it's the hardest working circuit in that TV set, and it's got a lot of voltage going to it. It uses a special transformer called a Flyback Transformer, and the Flyback Transformer is driven by the horizontal circuit, the output stage of the horizontal circuit, the last output stage, the horizontal collector, the horizontal output transistor, the collector of that transistor. DC voltage on that transistor might only be around 120 volts, but there's a waveform on there. There's a big horizontal pulse on there. And that horizontal pulse waveform, going by memory here, but I think it might be in the vicinity of 1,000 volts peak to peak. It's up there. And that, if you took a conventional scope from that time and you put it on that horizontal output collector, you could damage the input circuitry to the scope. The scope just can't take it. This scope could take it. This was the first scope. So that was that was the first big selling point. You know, the salesman, he says you can't do this with a regular scope, and he hooks that hook of that probe onto the collector, and we're looking at this big waveform, which is the horizontal pulse going to the flyback transformer. And we hadn't seen one before other than pictures or drawings or diagrams, because we hadn't had a scope that could do that, so that was a big deal. And then again, because they geared this towards the television service industry, you know, normally you would fiddle around with this until you found the proper time base so that you could see the waveform just the way you wanted to see it. Well, what they did here was, if you set this all the way down to this bottom position right here, they have two switches right here, and this one is video vertical and video horizontal. So that puts the time base right at the horizontal frequency rate for standard television back in the day. I don't remember what the frequency was. But anyways, frequency wasn't super high, but the whole point was that now you just, with a push of a button, and then if you brought this, your trigger, okay, for your scope, there's an auto mode, a normal mode, which a lot of scopes had, but then this had a TV mode. So you put this in TV mode, put this on horizontal, put that right on the leg of the transistor in the horizontal circuit, and this will automatically lock onto the waveform and show you a nice pretty picture. No fiddling around. So it's pretty cool. 15,750 hertz, 15.75 kilohertz. That number just popped in my head. That might be it. Or is that an IF frequency for something? I don't know. Hey, vertical was easy. Vertical was 60 cycles because it was tied to the 60 cycle power line. And by the way, that's where we, not to get too technical and go down that road, but 30 frames per second, 60 frames per second, that's all tied to the vertical power line, 60 hertz input power that we have. All right, so and you know, now I couldn't even tell you what the horizontal frequency is in a modern like plasma set, because the technology is just different. All right, so I was talking about probes, right? This is why I can't be a teacher. All right, so that's a direct probe. So we'll put that on the side here. Then we got, what do we got here? This is a probe. This is a probe. This is a switchable probe. This is a Hitachi probe. There was an old Hitachi scope there, and it was in really bad shape too, but that was in such bad shape, and I didn't need more than one scope. This is the one I wanted. But I grabbed the probes because I knew that was going to go to the trash anyways. It was only like a 30 megahertz scope or something, or 20 meg scope. Oh, this, by the way, this was rated when it came out as a 60 megahertz scope, but they always told us it's rated 60, but it's usable to 100. That's what they would tell us at Sencore. Sencore told us that. So, look at that. See how that's going freaky? It shouldn't be doing that. That is electrical noise that is in the circuit. Something is unhappy in there. All right. So this probe right here, this is a this is what they call a this probe can be switched from ×1 direct to ×10. So this can do double duty. And then you've got this is your ground. So this is how the Sencore ground was, only the Sencore ground is wider, so I don't think this will fit on here. Not even close, I don't think. Nope. So the problem I'm having right now is I don't have a ground wire for my Sencore probe. Alright, so this is Hitachi. These two are also Hitachi, but these are both direct. This has got a different kind of setup here. Look at that. This has got the little pin sticks in there. Okay. So if I want to use this direct, I could. Like I said, I have to compensate. So let's put the Sencore one on. And I don't have a ground, so I can't use this in a circuit for analysis. But what I can do is I can use it on here because this is grounded through this output right here is grounded through the same circuit, so it doesn't matter. I don't have to hook a ground up to measure off of this point. We got something there. Alright, so we're going to put this back to auto trigger. Source is channel A. And we're going to get off of this. And we're going to focus this. That should be nice and sharp. I don't know why that looks so. Take this off of here. Look at that. Is that all noise coming in from here? Sure is. Yeah. So, if I put that on the reference line right there, and then I put this on, then things go squirrely. Alright, so let's try that compensation screw. See if we can't clean that up. I prefer to have an insulated screwdriver to do this. Not because I'm worried about getting a shock. There's no voltage present here. Well, technically there is, but not. What I want is a screwdriver that's not going to react, because that's actually a little trim capacitor that I'm adjusting in there. All of the precision screwdrivers I have over here are gigunda compared to what they expect me to be using in this. There we go. So all that's going to do is square up the waveform. You can see what's happening. The leading edges of the waveform are going wacky. So that actually was already pretty good. But all of this noise on the top of the waveform shouldn't be there. Picking up a lot of garbage. That's why the ground is so close to the source here. Now I'm on the collector of that transistor back there, and you can see this is voltage peak to peak. It's flashing all 8s. It's saying, hey, that's a lot bigger waveform right there than what you got it set for, buddy. So now I'm bringing it down, and it's telling me it's 10 volts, 4.6 volts peak to peak. And obviously frequency wise we got something weird going on here. What the heck? Oh, that's weird. What the hell is going on? I don't know what I've done latched onto there, but that ain't good. That was 103 volts DC there. But there's some kind of a funky waveform there. Either that or this thing is very, very sick. 15.35 hertz. Not kilohertz, hertz. That's got to be noise that's measuring. That must be just straight DC there, and for some reason it's picking up noise. Well, the some reason is, again, I don't have a ground. Alright, let's try this 10 base probe, the Hitachi one. So this I can't check the DC voltage present at any point because of the fact that you know, doesn't have the capability to do that, but oh yeah, there we go, much better. See how clean that waveform is? So compensation on this probe is up here. So if I take this like that, I can see that I don't think that screwdriver I had is going to work here. Alright, it's been a few days since I was down here and the battery died on the camera. Last thing I was going to do was I had tried out this probe and it seemed to be working pretty well. And I was going to adjust the compensation on the probe. So, let's see. So I got this jeweler's screwdriver here. This is the right size to adjust. So the metal from the screwdriver actually affects the settings. So when I put the screwdriver on there, well, actually in this particular one it doesn't do it, but sometimes it does. So see, I'm adjusting that. What I want is I want a nice square wave. I don't know why it's doing that. Get some corrosion on the contact here, maybe. Maybe that's dirty. Of course, the phone rings as soon as I get down here. Alright, so I forgot to turn the camera back on. I came back down, but I just finished adjusting this. So it's a nice square wave. So basically when you adjust this, if I start turning it in one direction, you can actually see the alright. I switched it to direct for a minute because I was checking something else out. I had to switch it back. Well, there's something screwy going on here. This might be a bad lead. Oh, there we go. Alright, so son of a... Oh well, just unscrewed the lead here and you can see all corrosion inside there. Yeah, this is an unhappy probe. Now I can't get a square wave at all. Yeah, that funky thing. Put it on direct, it's fine. So this probe is bad. Curious, if I take this off and just go direct with this, yeah, it's still screwed up. Alright, so that Hitachi probe is buggered. So what I did was I was able to get this ground clip from the Hitachi probe to actually fit on the original Sencore probe here. And sure enough, that cured the problem with that distortion that I was getting on the Sencore probe. And so now I got a nice clean looking waveform and I can adjust the compensation here. And what I'm looking at is I'm looking at the leading edge of the waveform. If you look at the top of the square wave, it's kind of slanted, and if I adjust the compensation, you can see that like it goes down. Go the other way, it goes up. And what I want is I want it to be as square as possible, like right there. Okay. and it looks pretty good. So it's not perfect. And I just realized that when I was adjusting this and playing around with it, that all the controls and everything that I cleaned, the ones I forgot were the voltage peak to peak ones here, because you can see how that's how erratic that is. So I need to clean those contacts.